Recording. Yay. Alright. Off we go. 2 branches. So today is a magical day. We get to do one thing or another in code because right now we're just doing a bunch of stuff in order. We can be fancier than that. So let's see. I have a bunch of examples as usual. Again, I'm giving you all this stuff. I'm giving you all my code. Don't feel like you need to memorize every little bit. The goal is to get you to understand computational thinking. And I'm going to give you a bunch of examples of that, and eventually you'll be able to come up with these things yourself. Okay? So this is just more training. Everything I do is to prepare you for your Zybook stuff, which is also then used to prepare you for your labs, all that fun stuff. I don't know if I told you before, but all the tests in this class are open books, open notes. Just can't talk to a human or an AI chatbot. That's my only requirement. Everything else is fair game. Go on Stack Overflow if you've seen that website yet already. Everything I talk about is just to help you, all right? I'm not forcing you to remember anything, because you can just look it up on a test, all right? So let's get started with newer things. How are we doing with Nano and Vim? Have we all learned that Vim is better than Nano by now? I hope that we have. I hope that I'm slowly poisoning your minds in that regard, but if you would like to get out of the terminal and edit things in a different way, I can show you Visual Studio Code on your own computer, hook it up with the class server, but again, I'd rather you get good at doing stuff on the terminal just in case that breaks one day. But Vim or Emacs, those are the 2 competing editors that people love on the terminal. Nano is just for quick stuff, not really good for programs. If you want to get good at Vim, remember that you got the Vim tutor command available. It'll teach you how to use Vim. All right. And if you have a question about anything, Vim included, about some terminal command, there's a manual for the terminal, and there's a command called man. You just say man, the name of the command you're wondering about, and it will tell you about it. So you can say, all right, man ls, what does that do? Oh, and you can use the arrow keys or the Vim move around keys and Q to quit out of this. It's like, oh yeah, ls stands for list directory contents. There's some extra things you could give. ls-a shows you all of the hidden files. Like my directory is empty, but ls-a shows some stuff. What is all that? Man G++. This is a very long manual page, but it's a compiler. It's fancy. Read that if you're interested. But yeah, man cd, what all of these things do? Okay, cd is too simple. Man pwd, print the name of your current working directory, and there's options for that apparently. Cool. So yeah, look things up in the manual if you're interested. And now we're ready to get to the meat of today. We want to ask questions and make decisions based on the answers to those questions in our programs. Because, let me try and motivate this for you, it would be nice to be able to do one thing or another. Right now, all of our programs look like this, like statement A, semicolon, statement B, semicolon, statement C, semicolon. And this is what it looks like if I were to draw like a flowchart form of how the program works. Like first do A, then do B, then do line C. That's how our programs look. They're just straight lines, kind of boring. Right? For example, we can't do something like this. We can't print even or odd to the user if they give us a number. We have no way of doing that. Because that would require us to be doing something like this, like first get the number from the user, put it in like an X variable, and then ask the question, is X even? Question mark. And then branch off. Like if the answer is yes, then print even. And if the answer is no, go off and print odd. We have no way of splitting like that right now. I hope you see that it would be nice to have. And maybe once we're done with all that, we come back later and do some more straight line code down here at the bottom. Whee, dot, dot, dot. But just branch off for a second. That ability, we don't have it yet. At best, if we want to print even or odd, we can get close. We can be like, first get the number from the user, and then we could print. We can't print even or odd, but we could print x mod 2. And if it's a 1, it means it's odd. If it's a 0, it means it's even. So you can do math still, but we can't just print even if it's even and odd if it's odd as strings yet. Okay, so let's get there. Let's be able to do that. I hope that is logical and something you understand we would want to do. So here's a silly example. I, as a millennial, grew up with Mean Girls. Hopefully we've at least seen the memes about the movie before. But one of the catchphrases from the movie is, on Wednesdays we wear pink, so I'm going to write a program around that idea. All right? So I want to write a program that asks the user, is today Wednesday? Or ask them what day it is, maybe. And then ask, is that day Wednesday that we just got from the user? If so, if yes, do one thing, say that we should wear pink today. Otherwise, say that we shouldn't. All right? So we are going to ask this kind of question in what's called an if-else statement in C++. It looks like this. Here's what the code will look like. You say if, you put something in the middle called a Boolean expression. We'll talk about that in a second. And then you put some braces for what you want to have happen if that thing's true. And then you say else, and you put some braces for what you want to have happen when that thing is false. And so those are important. Boolean expressions, they're just values that end up being either true or false. Those are keywords in C++. And that's yes and no. Instead of yes, in programming land, we say true. Is today Wednesday? Is that a true statement? That means yes, and no is false. All right? So I'll say true and false instead of yes and no. And so we're going to write code that looks like this. Something here is going to become either true or false. And if it's true, this code gets run. And if it's false, this code gets run. That's how you split off. All right? And that's going to be the program that we write eventually. I need to talk to you about how to make Boolean expressions first, because we don't know how to make anything that becomes true or false yet. Well, let's go there. All right. To get true or false, you have to use, usually, what's called a relational operator. This is all the stuff from math that you know and love. If you want to check if something is equal to something else, remember that the single equals is overloaded. That's already assignment, so you have to add a second one. Two equal signs means check for equality, give back the answer, true or false. So 2 equals 2 will give back true, because that's, yes, 2 is equal to 2. Yeah. Instead of not equals to written like this, that's hard to type on a normal keyboard, we have the exclamation point and an equal sign. Read the exclamation point as not. So that stands for not equal to. That's a relational check. So is 4 not equal to 7? Yes. So true. See that? And then you have your normal relational operators. So is 2 less than 3? Yes, true. Is 2 greater than 3? No, false. It's also hard to type less than or equal to like this. And so we just put a less than and then an equal to sign right next to it. So is 2 less than or equal to 2? Yes, it is true. Is 3 greater than or equal to negative 42? Yes, true. Is 3 greater than or equal to 5? No, false. So that will evaluate to false. Okay? But all of these things become either true or false. C++ does the checking for us. And so you could plop these kinds of expressions in the Boolean expression part of an if statement, those little parentheses, and then it will evaluate it will execute one piece or the other piece depending on if it was true or false. So like if I say if 2 is equal to 2, remember 2 equal 2 to check, do some stuff, else do some other stuff. All right, let's just have empty bodies, or empty pieces right now. They're really called bodies, and I'll get to that in a second. So is 2 equal to 2? Yeah, so this is always going to be true. So this code will always run whatever we put here. It will skip whatever is put here. But I think you can imagine if you changed it, it would be different. And usually we don't put silly things like this. We put things involving variables that we get maybe from the user. And so it has the possibility of going both places. All right? But it's always going to execute either one piece or the other piece. The piece where it's true or the piece where it's false. And those pieces are called branches, by the way. This is the true branch. This is the false branch. There's lots of terminology there. But now we can make that program. Let's make the should we wear pink program. Here's what it'll look like. First, we get the input from the user. We'll ask them what day it is. Is that input day equal to Wednesday? If so, if yes, true, we'll output, hey, we should wear pink. Otherwise, in the else part, we will output, don't wear pink. And then we'll come back together with more straight line code, and that'll be it. So let's get started with that. So I'll make a new file called ifelse.cpp. Alright, so let's get the day of the week from the user as a string. So I'm going to need the string library. So string, I need a Save away the day, so today, string today. Get that, so let's output first a prompt, enter what day it is, please, user, colon space, get it, it's only a single word, so I can get it from CN, read that into the today variable, and then if today is equal to Wednesday, then output, wear pink, else, otherwise, if that's not true, if it's false, output don't wear pink. Yay. And you could, like, after one or the other, one of these runs, the whole thing's done. And then you can just put more normal code down here. So more straight line code can go here, dot, dot, dot. You can have more if-elses too if you want. And then just to prove to you that this code is always going to get run, just let me output cout done or something. There. And then we have a return 0. I don't know why that's taken so long. Save. Well, let me restart my Vim. Sorry, I don't know what it's trying to do. It's taken too long to do it, though. There we go. Alright, so there's the relevant part of the program. G++, if else, dash O, if else. Enter what day it is. Well, today is Thursday, so Thursday. Hit enter. Is Thursday equal to Wednesday? No, false. So it's going to hit the else part. It's going to run all this code between these braces, and it outputs don't wear pink. And then it's done with the whole thing at that point. It's chosen which side to go down, and then it's done. So it's done down here. I have more code down there, of course. If I rerun the program and pretend that it's Wednesday, hit enter. Is Wednesday equal to Wednesday? True. So where pink gets output. We skip the else part. And then after we've picked a side to go down, the whole thing's done. We start running the rest of the code down here. Printing done. Any questions about this? This is an if-else statement. You can do one thing or another thing. You can have as much code as you want in both of these pieces. You can have multiple lines if you want it. So that's a good start, I think. We can now actually do the even or odd example from the start. Let's see. And then I'm going to teach you some terms too. So we're going to get the input from the user. We're going to ask them for a number. And then we're going to go off and check, is that number even or odd? And we need a condition to do that. We'll get there in a second. So based on that condition, if it's true, let's say we're checking for evenness. So if that's a true statement, whatever we come up with, to check if something's even. If it ends up being true, we'll print that it's even. If it ends up being false, we'll print that it's odd. So now the question is, how do you check if a number is even or odd? You can do what I was saying up here just briefly. You can do modulus. Modulus by 2. Try to divide a number by 2 and get the remainder, because if I take an even number divided by 2, that's what? 21. Remainder 0 when it's even. That remainder means it's even, right? 2 goes in cleanly. If I try to divide 43 by 2, I again get 21, but I get remainder 1 this time, and that tells me it's odd, right? So just checking that, getting the remainder after dividing by 2, that'll tell us whether or not we are even. So let's check for evenness. So get our input. Let's pretend the input is called input. So we need to write a statement here that gives back true if it's even, because that's the side that I want to go down when it's true. So if input mod 2, that'll get me the remainder. If it's even, it's 0. So I want to check for 0. If that is equal to 0, that will be my condition. Does that make sense? If this side becomes 0, 0 equals 0 is true. It was even, print even. All right? That's how that's going to work. And that will be my condition. So let's code that up. Even odd.cpp. So let's ask the user, let's make room for a number. Ask the user for a number. Colon space. Get it into the n variable, and then, so I'm calling it n instead of input. If n mod 2 is equal to 0. If dividing by 2 results in a remainder of 0, that means there's nothing left over. It was even. And so I'll see out even exclamation point, new line. Otherwise, if that was not true, the only other option is that it was a 1 remainder, so it's odd. See out odd. Exclamation point, new line. So there's the code. Boop, enter number 42. Hey, that's even, because there's a remainder of 0 when we divide by 2. Number 43, hey, that's odd, because it's remainder by 2 is 1. It's not equal to 0, so that's false. It goes straight to the else. Okay, so that's the code. Any questions about the code? Does that make enough sense? I have some terminology for you. I was trying very hard to not say the terminology accidentally. I did say it once, so sorry. But here are the terms that you need to know now. The part in between parentheses, the thing that gives back true or false, that's called the condition of your if-else. We want to see if it's true or false. It is our condition. Okay, that's the right size and the right color. So this part is the condition of our if-else statement. The thing that gives back true or false, the thing that drives which side we're going down. And the sides, like the pieces in between these colon, or these curly braces, those are called the bodies. Like, I don't know, you're drawing a stick figure and like all the meat is in the middle. That's the code that you want to have execute. These are called the bodies of each piece. This is the body of the if, of the true branch. And this is the body of the else part, the false branch of else. So who knows why they call it that? I assume it's because it looks like it's like in the middle, where the condition is like the head. But this is the body of the if statement, the body of the else statement. That's how it's working. All right, so that's some terminology, and that's our example. Are we still good? Lots of new info today. One thing I do want to say is you don't need to include else sometimes. Like sometimes you just want to do something if a condition is true and just do nothing if it's false. So you don't need the else if you just want to do nothing. You don't need to have an empty body there. You can just put an if statement by itself without an attached else. So this will just check the condition. If it's true, it executes the body. If it's false, it just skips the whole thing and just starts running the rest of the code. All right? So you don't have to have else if you don't need it. Get rid of it. Let's see. Oh, this is a fun one, if we're still happy. Oh, man. What's the best way to show this to you? Where am I going to put this is the next question. Do I put it here? Okay, I'm just not going to put it on code just yet. Here's a very fun fact. It will lead to some issues eventually, but I promise it's useful for some things, just maybe not in this class. Numbers can be implicitly translated to true or false. And so numbers that give you back, that can be translated to true are called truthy. And numbers that can be translated to false are called falsy. So if you use a number in the place where a Boolean expression should go, C++ will make it a Boolean expression for you in a very weird way. So C++ implicitly converts values to true and false if they're part of a condition, and it needs true or false right now. All right, so please watch out for this. Every number in C++ other than 0 is truthy, so it will give back true. All right, so if you can legitimately write this, if 42, and you can have a body, and it will run that body. It will run this because 42 gets translated into true. It's a truthy number. Weird. You can legitimately say that. You can also say if 0. 0 is the only falsy numbers that gets translated into false. And so it won't run the body of the if, but if you had an attached else, it would run that. Disgusting, I know. So that's the part that would get run. So if 42, it really will run the body. 42 is true to C++. Anything other than 0 is true. So 0 is false to C++. Yeah.
So it's just saying if 42, like there's nothing else attached.
No, all it's looking for right there is a Boolean expression. It needs something to be, it needs to become true or false, and numbers are able to become true or false based on this rule. So this gets replaced with, it's like, oh, all right, that's true. And it's like if you said if true.
So, in theory, you would put x equals 42 if x had run that code?
Yes. Yes, because x would get replaced with 42, which would then get replaced with true. Very good. Yeah, weird. Any other questions? So good thoughts. So, all right, I have a question for you. Please go to the buy clicker page and you'll help each other. I'll give you another minute to do attendance. I'm going to stop that by the time we're done with buy clicker. But let me start the timer for you here. And here is my question for you. Please help your neighbors get into peer instruction groups. Say hi. Here's some code. Please tell me. There's an if-else statement. There's a relational stuff, right? Tell me what's going to print. Print, it was 42. It was not 42. Please run this code in your mind first. This is how we get practice, right? But tell me if it's going to be A or B. Let's see if we're awake. Let's see what we're thinking. I'll give you 2 minutes to discuss and say hi. Did I click record? What will it do? Or no, it should be quick. Let me give you 1 minute. I hope the question makes sense. If else, we got a condition. Let me watch the numbers go up. Another few seconds to discuss. All right, get an answer in. Click something. What do we think? Oh, somebody says C. That's valid. So a majority of us think B. And all right, cool. Let's talk about it. I'm gonna stop attendance now too. All right. Well, let's go to code. I'll just copy and paste all this. Hopefully, PowerPoint's sometimes bad with copying and pasting. We're gonna see if this works. I'll call it 42.cpp. Yeah, it hates this. It made the quotes fancy. We gotta fix that. Is there anything else that's wrong? There's a tiny little warning sign there. That's foreshadowing something. 42. 42. It was 42. Huh.
Oh,
You see it? Does anybody else see it? What's wrong?
it's not x equals.
This line, that nicely underlined thing by my editor, it's being very helpful here. What is this doing?
Setting x to 42.
It's an assignment statement. It's an assignment statement. It sets a value. What should it have been?
Equals.
Double equals, yeah? Okay. So that's disgusting. So it was A. This is a trick question. Yeah, I'm doing it right now because it's going to happen to all of us in this class. All right? So this, first of all, is again why this should be called arrow rather than equals. It should have been this so that we wouldn't have seen any issues here. So remember, double equals checks for equality, gives back true or false. Equals is assignment, all right? So, silly. And, all right, so a number of things happen to make this even compile. So you're actually allowed to put arbitrary code in a condition. You could say, you're allowed to say if x equals 42, if assignment statement. That's totally fine. And it will run this code, right? So here was x, it was 41. As it checks this condition, it will run that code. You're allowed to put an assignment statement there. So it will run the code. It will set x to 42 if it wasn't already 42, first of all. And then the result of an assignment statement, as far as C++ is concerned, because it needs to translate this to true or false eventually. The result of an assignment statement, weirdly enough, is whatever you just put into x. The result of an assignment statement is whatever the right-hand side became. So this translates into if 42. All right, which then, of course, we know translates into if true. So not only did it set x to be 42, it will also run the body. So watch out for this. If this was x equals 0, it would set x to 0, but then that's false. So it would then run the else statement instead of the if. So it's just because 42 is truthy, does it run the true body. So that's fun. The result of an assignment statement is the right-hand side, so the 42 is the result. And we need to translate this into either true or false. 42 is true. All right. So this is disgusting. You would probably hope that this is an error, right? C++, why didn't you just not let this compile? Why are we allowed to do this? So first reason is because every statement, it usually gives back a value. It's able to do that. So you would think that the assignment statement doesn't give anything back, but it does. It does result in something. And so you can use it in a larger context. And so if this is allowed, there must have been a good reason, right? Here's the good reason. Here is why the assignment statement works like this, and why you have to watch out. If I make a couple variables, int x comma y, and keep them uninitialized, you can set a bunch of variables at once by chaining assignment statements. You can write a line that looks like this: x equals y equals 42. And this will set both of those variables to 42 at once. The reason this line works is because C++ is drawing parentheses around your code this way. It's running things in this order. It's doing this. So it's setting y to 42 first, and that's going to result in the right-hand side. So it's getting 42, and then it's like, all right, and then I'll set x to 42 because that was the result. That's the only reason this works. That's the reason you run into this issue, because you're allowed to set a bunch of variables on one line, because assignment statements give back their value that they set. That was a lot of words. So that's disgusting. Just watch out. Make sure if you're checking for equality, you better be typing 2 equal signs, right? This will bite each and every one of you in this class. I'm just telling you now so that you remember. And hopefully you solve the problem a little bit faster than otherwise. Any questions about that? Before we get fancier with our if-else's. All right, so on we go. Let's talk about nesting. You can put ifs inside of ifs. What is an if-else statement but code? What is the body of an if statement but a place where you can put code? So you can get fancy. You can say, all right, if x is even, do all of this, which is another if-else. Totally fine. Then you can check if x is positive. And so if you get in this innermost body of this innermost if statement, then you know that because you got to the if statement at all, it must have been even, x was even. And then if it was true, x was positive, if that was a true statement, then you know that if you're here, x was even and positive. See that? Because the only way you're running the body of this outer if is if x was even. If that's not true, then if you get here, you know that x was even and it was not positive. Okay, see how I'm reading that? You'll get good at that, I promise. And then otherwise, if you skip all over this whole thing, that means x must have not been even if you went straight here. X was odd. So this is the flowchart form of what's happening. Like we jump into here and like here, hey, we ask, was x even? Because that's what if-else's do, or just ifs. That's what they do. They check their condition. If so, if it's true, they run their body. So it's got to check this first. That's how C++ is running this. If that's true, then it's got to run all this. which again is an if-else. How does an if-else run? It checks its condition to figure out which body to go to. So, all right. Then it checks, hey, is x positive? If that's true, we're in body 1. We know that x was both even and plus for positive. Yeah. If that was not true, we go to the else. That means x was positive. We know that because we were here. But, I'm sorry, x is even. Sorry, we know that because we got here. So x is even, but it wasn't positive. So it was either negative or 0. That's the idea. So that's what happens if we go down this body. And the second, like, we're done with all that, we go to 3. Like, we're done with everything. We're done with this inner body, which means we're done with the outer if. We picked a side to go down. We can just move on to the rest of the code. That's part 3 down here. So like that, just all continues to there. But if x wasn't even to start with, what's going to happen? Like, it checks this. Right? If it wasn't even, if it was odd, it skips this whole thing. It goes straight here to the rest of the code. So that's how this will execute. False. Do you see how I'm reading that? Any questions? You'll get better, I promise. But I want you to at least vaguely understand how this is working right now. All right, and of course you can have more straight line code down here. Could have also had an else attached to the outer if. So you can put ifs inside of ifs, and that's useful. That leads to a new piece of syntax. Sometimes it gets a little disgusting putting ifs inside of ifs inside of ifs. And so let me show you how disgusting that could get. There is a pattern to make that cleaner looking. It's called else if. Right? So let's do it the hard way and then the easy way. So here's a silly example that exhibits a very common pattern that you have in your programs. You ask, hey, is this true? If so, do this. Otherwise, okay, if that wasn't true, try this. Then do this other thing. Otherwise, if that wasn't true, then try this. If that's true, then do this. So just a bunch of alternative patterns with priority order. That's a very common thing to want to do. So let's write a program that abbreviates days. So, I don't know. If the user types Monday, we'll have it output mon, like we're printing a calendar for them and it's very small and it needs to be tiny. Let's abbreviate every day for the user. So if they type Monday, we'll give back mon. If they type Tuesday, we'll give back 2. So really I should probably be typing Monday, Tuesday. It just won't fit. You'll get the idea when I talk about it. But that's going to be, this is kind of how we want it to think about structuring this program. We're going to get we're going to get a string from the user, what day it is. And if the day is Monday, we'll output mon. Otherwise, if that's not true, then we got to check if it's Tuesday. Maybe it's Tuesday. Check if it's Tuesday, output 2. Check if it's Wednesday, output wed. Only one of those ever needs to run, though. So here's how the code will look. Here's the way that we know that the flow chart. This is going to be the way that it's going to execute no matter what. So if the day, let's pretend that the variable is called day. If the day is called Monday, double equals. If that's true, then we want to output mon, right? Because we're trying to abbreviate days. So we say mon. Otherwise, if that's false, then, all right, it wasn't Monday, maybe it's Tuesday. So check. There, we have another check now, so another if. If day was Tuesday. If that's true, then we output 2. But if it was Monday, we're done, right? We don't need to continue checking anything else. That's the whole point. It's only one side's we're going down. All right, true. Output 2 when we're done if it was Tuesday. Otherwise, if that was false, well, then maybe it was Wednesday. See the pattern? Then, all right, check if it's Wednesday. We'll abbreviate that. So there's that. If that's true, output wed. And you see the pattern, right? If that's false, then it's time to check for Thursday in some order. But only one side. Once you find what day it is, like output that thing and you're done. That's how we want to structure this. Let's write that. And I'll make this file called else if, because that's going to be the pattern that I show you in a second. Else if.cpp. So I need to get a string from the user, so I'll include the string library. I will get the day from the user again. So cout enter day. And then we'll get it. And so now, all right, let's make this into code. So the first thing we gotta do is check if today is Monday. If day is equal to Monday, If that's true, output mon. That's its abbreviation and be done. That's everything. Else, if we get here, it wasn't Monday. All right, that means we have to check now. Was it Tuesday, Wednesday, ... We got to try them all down here in the else. But if it was Monday, the if is done. We went down that body. We're done with the whole thing. Otherwise, we're here. And now we got to check again. If, all right, maybe it was Tuesday. If day is Tuesday. If that's true, go down this body and say cout 2, new line. So that's true. Do that and be done. Otherwise, else, this is getting kind of disgusting. Else, all right, it wasn't Tuesday, and it also wasn't Monday if we got here. It wasn't Monday or Tuesday. So let's try Wednesday. All right. And again, if it was Tuesday, bam, it outputs Tuesday, skips over the else. This whole thing's done, which means we're done with the whole else, which means we're done with the whole darn thing. So it's really only going to go down one innermost body somewhere, the way that we're structuring it. All right, if it wasn't Monday or Tuesday, if day is Wednesday. Cout wed, new line. And then I'm going to go faster now because I think you get the idea. All right, if that's not true, it wasn't Monday, Tuesday, or Wednesday. So let's check for Thursday. And just for my sanity, let's just do weekday abbreviations, only up to Friday. So if it was Thursday, cout the. And then otherwise, let's pretend the only other option was Friday, and so we don't even need to check. So if it wasn't Thursday, and also none of the other ones because we checked those first, then it must have been Friday. All right, must have been Friday, or the user spelled the day wrong or something. All right, let me try to zoom out and show all of this to you at once. I'll do my best. Cool. So we get the day, and then here it is. Here's this monstrosity. If day is equal to Monday, output mon, we're done. If day is Tuesday, all right, this was false. We skip over this, go to the else. Then we start checking, okay, if it was Tuesday, output 2, and then we're done. Because it's going to skip this else, and everything's over. Otherwise, if it was Wednesday, all right, was it Monday? No. Was it Tuesday? No. All right, we're in this else now. All right, if it was Wednesday, yes, output wed, we're done. We skip over this else, which means we're done with this inner if else, which means we're done with this outer else, which means we're done with this if else, which means we're done with this whole else body, which means we're done with the whole if else. That might not make enough sense right now, but there's a reason I'm saying those words. Then if it was like Thursday, it's not Monday, we hit the else. It's not Tuesday, we hit the else. It's not Wednesday, we hit this else. It's not Thursday, or it is Thursday, so we print it. And I think you can imagine what's going to happen when it's Friday. So let's run this. So we're trying all these options, and only one. Once we find one that works, we're done. That's how this is working. Enter a day, Monday, mon, Wednesday, yes, wed, Thursday, the, Friday, fry. It's all working. I guess I skipped Tuesday. 2. It's hitting everywhere. Are there any questions why it's working? Does it make sense? Can you follow it? It's weird. It's disgusting, but it works. There's a lot of indentation. There's an easier way. Let me show it to you. So it's called else if. If you shove else right next to if, you can get rid of indentation and a lot of braces. And so here's the pattern for trying alternatives. It actually corresponds more to the English-like game plan anyway. So you will grow to prefer this for sure. So here's how to use else if. It's like if, try this first thing. If that's true, do this. Do the body, sure. Then you say else if together. Else if this is true, put another condition, put another body. And I want you to read else if as otherwise. So if this condition is true, do the first body. Otherwise, if this condition is true, do the second body and be done with it. Else if, a third alternative, if this is true, do this body, ... as many else ifs as you need, and then one last else to say, otherwise, if none of that's true, then do this one. That's the pattern, and it's much cleaner, much less indentation, and it looks more like English anyway. So, okay. I'm going to rewrite all this into equivalent code. It's going to do the exact same thing, but it's going to use else if. So I'll copy and paste it so that we have both. It will output both the same both times. So the first one we keep, if day is Monday, do this. And then else if otherwise, if day is Tuesday, output 2. See that? All right, if that wasn't true, else if day is Wednesday, output wed. See, I'm getting rid of a lot of indentation right now. Otherwise, if that wasn't true, else if day was Thursday, output the. And then finally, if that wasn't true, you can output Friday. Sure. And then I don't need any of these braces anymore. Which would you prefer? This is the same code. It's going to run the same way. It's much cleaner. Just read it as otherwise. If day is Monday, do this and be done. Otherwise, if today is Tuesday, just do 2 and be done. It's only going to ever run one body as usual. It'll pick the first one that matches. All right? Otherwise, if none of those are true, none of those match, Friday is the output. And so this will do the same as the one before. Monday, I see mun twice. It really is doing the same thing. Tuesday. Oh wait, sorry. I think I spelled it wrong. Tuesday. There we go, 2. If you make a mistake, it's gonna go to the else and think it's Friday. Wed. Fry. Alright. So read else if is otherwise. Otherwise, if this is true, okay, do this. Okay, otherwise, if that wasn't true, but this is, do this. Much cleaner than this. Though this might make more intuitive sense to you right now. I can imagine that might be true. But you will grow to love this one. It's cleaner looking. Any questions about it? Alright, I can zoom back in now. Okay, so I have a question for you to try. Let's go to the written nice page. I really need to change these slides. As a group, here's a question for you. I'll clear it out for all of us. Delete. Here's my question for you to try as a group. You can pick one person to be the, I'm going to press submit if you'd like. But here's the code I'd like you to try writing. So write some code to using a double variable called grade. And you can hard code values, get it from the user. But I just want the if-else parts. I would like you to output, pretend this is a simplified grading scale. And I'd like you to output C if the grade variable is between 70 and 89.99999 on forever, just less than 90, right? Output F if the grade is less than 70. Apparently, it's only A, C, and F that you could get. And output A if the grade is greater than or equal to 90. And so, if you structure it right, you can get away with these being your conditions. You'll have to reorder things. So figure out the order, and then see if you can get some code in. So let me show you this pattern all over again. I'll copy this code because this is kind of how you're going to want to do it. I'll put it over here tiny if you want to look at it. But take a few minutes, give this a try, pretend you have a variable called grade, and try to take grade and output A, C, or F depending on these conditions. Okay? Questions about the question? So give that a try, help each other, and we'll come back in a few minutes. We got plenty of time. Whee! Another 30 seconds or so. Four, three, two, one. All right. Let's take a look at what we're thinking. All of our brave groups who have pressed submit. Thank you. Nice. We got some full programs. Very nice. I like it. Good. Yeah. So the very first thing you should be checking is A. Otherwise, it's like if it's greater than or equal to 70, it's also greater than or equal to 90, right? So it's only going to pick the first one. So that's good. Grade greater than or equal to 70. So that's going to be the proper order. Good job, group 14. I'm picking on you right now. This is perfect. Grade greater than or equal to 90 first. Then check grade greater than or equal to 70 second. And then you don't even need a condition for the last one. It'll just be the opposite. All right. That's the idea. Any questions about that? So I'll show that to you in code. But let's come back. Let's come back and I will let you talk to each other again soon. All right. So let me code this up for you and let's watch it work. Let's do a new file called grade.cpp. All right. Can you guys please not talk while I'm talking? Thank you. All right. So let me code this up while I have your page open. So I really could just copy and paste this. This is a great job. But let's go through this. Let's walk through what needs to happen. All right. So that rearrangement is key. But let's get a number from the user. And let's get going down on here. So let's make space for that grade. And let's go and ask the user for it. Enter grade colon space. CN into the grade variable. And then we got to do something. All right. So convert grade to either A, C, or F. All right. So if you keep this order, there will be an issue. So let me show that to you. So if grade is greater than or equal to 70.0, output C. Else, if grade is, I don't know, less than 70, we can do 70.0 right now, output F. Else, if you don't need a final else, if you want, if you have a condition still, if grade is greater than or equal to 90, 90.0, why not? Then output A. Do you see why this is an issue? It's going to skip over something, because watch. Grade enter a grade, I don't know, 75, sure that's a C, but enter a grade 95, it also thinks it's a C, because is this true if it's 95? Grade is 95, is that greater than or equal to 70? Yeah. So do the hardest one to make happen first, the most unlikely one, do the highest number first. So this should be the first one you check. So if it's greater than or equal to 90, then it's A. You could honestly keep these other two in the same order. This could be C. This will work, as long as you're checking for 90 first. There's a lot of options, but this might not even be the cleanest one still. Enter grade 95, get the A. 75, we do get the C, because it skips it. If it's not less than 70, it just keeps on trucking and tries the next one. If it's 65, then we do get our F. But you could get away with, usually the pattern is largest number to check, second largest number to check. So maybe C should be second, because then you can make the last one an else. So here, let's try that. So greater than or equal to 70, then it's a C. And then else if grade is less than 70, notice how, if this is not true, what does it mean for a grade to not be greater than or equal to 70? It must be less than 70, strictly less than, if that is not true. So this could become else. It's just if it was false, it's an F. And so that's what a lot of us seem to get. Very good job. And so now we get 95, A, 75, or 85, still C, and then 65. Anything lower is an F. Any questions about this? So this is probably the pattern that you'll use most if I ask you to do a normal grade calculator. It's like, check for 90. Then if that's not true, check for 80. That's the next higher one. Then check for 70. All that fun stuff. Any questions about that? Yeah, good job. You figured out how to rearrange things, so thank you. All right, one last section, then I'll release your lab, and you can go off and do cool stuff together. So, I want to talk to you about a special type called bool. It is short for Boolean, and it holds those results of Boolean expressions. This is a type that holds true and false, right? It exists if you want to make a variable that holds either true or false, right? So it's called the bool type, just like int was a cloud that could hold on to some stuff, like what are valid ints, whole numbers, 42, 0, negative 40, all those exist. The bool type is very simple and small. It's a tiny little cloud. There's only two things inside of it. The only values in the bool type are true and false. There. So that's all. You can make a variable and the type name is bool. Say bool b equals, and you just give any Boolean expression and put it here. Anything normal. So 42 less than 43. This will evaluate to true, and then inside of the b variable will be true. And then, like if you had some complicated expression, you could use that as part of an if statement's condition. Like if b was true, if b gets replaced with true, if that's what it held, then run the body. Does that make sense? That's so cool. So you have a variable that you could, you have a new type to put Boolean values into. It's called bool. So let me show you some of that. Oops. Bool.cbp, I don't know, bool b1 equals, hey, is 42 less than 43? So that'll be true. 3. Bool b2, I don't know, store the results of 45 being greater than or equal to 55. And so this will be false. It'll hold false. And then you can also just hard code it. You'd be like, bool b3 equals true. That is a keyword. Bool b4 equals false, lowercase. So yeah, it'll evaluate these to either true or false if they aren't already true or false. And you could use them in bigger statements. You could also print them out. B1, B2. If you don't tell it otherwise, C++ outputs Booleans as numbers. So it's a little odd, but it's 1 for true, 0 for false. So if you print out a bool, you're like, why is it a number? It's doing that conversion for you. So it prints B1 as true, so 1 for true, prints B2 as 0 for false. Right? So that's how that works. And then you could use these inside of larger expressions, like if B1 evaluates to true, if it gets replaced with true, if that's what's holding, see out B1 was true. And it was. So it'll say yes. You can also condition on B2, like see out B2 was true. New line. Otherwise, see out B2 was false, and it was false. So it will hit this body. Whee, so B1, it really did hold true, and so it hit the body of it. B2 was false, so it didn't run this one, it ran the else branch. Because it was that. Any questions about that? That's Booleans. Alright, if we are happy, there's one last thing I want to show you because, at least for today, normally you don't just want to check, hey, is 42 less than 43, hey, is x positive, hey, is x even, all by itself. A lot of times you want to check, are multiple things true at once? And so you can combine your conditions with a new operator called ampersand ampersand, which is short for, it stands for and. This is the and operator, we say. 2 ampersands. And so instead of doing something like this, we're asking, hey, is the number even? Check that separately from checking if it's positive, and like having a body in the innermost one saying, all right, yeah, it was even and positive. That's kind of clunky. Instead, you could use the and. You can just do it in one if. Just check, hey, this is equivalent code. Is this true? Is it even? And is it positive? All at the same time. If both of those are true, run the body. That's kind of useful, right? So, and works in exactly the way you would imagine, but just to get us ready for other kinds of combinators on Booleans, let me give you what's called a truth table, all right? So B1 and B2 results in true when they're together true, when B1 is true and B2 is true, all right? So let's pretend like B1 is positivity, B2 is evenness. And so B1 ANDed with B2 is true. This is called a truth table. It tells you all the outcomes. Like these are the options for B1 and B2, and this is the output. This is what B1 ANDed with B2 would be under those conditions. So if B1 is true and B2 is true, that's the only time their ANDed togetherness is true. So the only time the AND operation on both of them together gives you back true. Because that's the question, right? Is B1 and B2 true? If one of them is false, the whole thing's false, right? That's the check. So the only way to make B1 and B2 true is for them both to be true. I hope that makes enough sense. But we can output the truth table, why not? And that's pretty much it. So see out. True ANDed with true, that's the only one that's going to be true. The rest of the truth table is it's all going to be false. Is true and false both true? No. Is false and false true? No. Is false and true? Absolutely not. So we should see 1 0 0 0 to mean true, false, false, false. That's just outputting the truth table over again. That's double ampersand to combine our conditions, and in them only this first one is true. Only this one is true, and that is useful, I hope. Any questions about that? That's all that I want to talk about today. That's Booleans. We'll do the rest next time. There's going to be more combinators, and the truth table will be helpful for them, I promise. But if we're happy, let me release your next lab and just let you go off and work and help each other. Lab 1. I think you get the idea by now. This one, it will be due next Friday, because you got one due this Friday. The next one will be due next Friday. This is Lab 1, due the 25th. Here's the write-up. And then we'll look at the starter code together, too. So actually give you code with stuff inside of it for this one. Files with stuff inside of them. So here's your Lab 1. There's a couple parts to it. This one's all about using library functions that we talked about last time, getting practice with those. So get the starter code with the gimme command. That'll make that lab01 folder in your current directory. And once you have it, let me show you what's inside. Starter code 4001. So once you use the gimme command, you will end up with these files, randomaverage.cpp and salestax.cpp. All right, so here we go. Probably this one's the easier one, so let's do this one first. So the first part of your lab is about random number generation. So I would like you to generate 5 random numbers between 1 and 100. 1 is possible and 100 should be possible too. And then I want you to print them out, and then I want you to output their average rounded to 2 decimal places. You're going to have to do double division. You're going to have to use that set precision thing that I was talking about before. Go back to the code from last time. I put a bunch of comments, so let's just look at the file and do that together. Remember that rand lives in cstdlib? Remember to seed your random number generator. I actually might be doing that for you. But here's that file, randomaverage.cpp. Yeah, I'm doing it for you. I'm already seeding it. But your job is to fill in these fix me comments. All right. So here, output or generate 5 random numbers, save them away maybe, because then we got to print this random numbers between 1 and 100 colon, then output your 5 random numbers on 5 lines, and then output this average colon space, the average of those 5 numbers that you just generated, rounded to 2 decimal places. All right. So remember that you can use set precision to do that rounding. You also need to use fixed as well. But just look at the code from last time. But that's pretty much it. You're going to use the rand function in cstdlib. Follow these all together. I think it should make sense. Right. So that is your random average file. And of course, because it's random, every time you run it, it should do different things. Like here's one run of it. Like here's that average. Second time, it will have 5 new random numbers, right? And they have their own average. So it's different every time you run it. And that's the whole point. It's random. Any questions about that? So it's just math, library functions, double division versus integer division, stuff like that. That's what I'm having you practice for this one. We good? So that's that code. Definitely take advantage of the starter code this time. Didn't just give you a blank file. So to compile as you would, as I've been doing, and then run it as you know how. So that's the first part. The second part of this lab is called salestax.cdp. So here's this file. And this is a fun one. This will hurt your brain for a little bit, but I do give you a hint at the end. So I would like you to write a sales tax calculator. Like your program is running on the teller's machine at the front of a store. And I would like you to imagine that we live in a different universe where we don't have any pennies or nickels in our currency. All right. So for this program, I want you to get an input price from the user. So they're going to tell you the subtotal or whatever, and then you're going to calculate. Let's pretend this was 10 years ago, and we have 7.75% sales tax for our items in the store, and you're going to calculate that sales tax in a universe where there's no pennies or nickels. So I need you to round this sales tax calculation not to the nearest cent like you would normally, but to the nearest dime. Ooh. All right, so you're going to have to think about that. You're going to have to round to the nearest tenth rather than to the nearest whole number, because you have the round function that rounds to the nearest whole number. You can't just tell it to round to the nearest tenth or 100th easily. There's a way. All right, so take a look at the CMath library. It tells you about the round function, but I showed it to you before. I also have a hint at the end if you want to read it. But here's what it's going to look like. All right, so you're going to get a price from the user. That's been saved away. And then you are going to calculate 7.75% sales tax on that price, round it to the nearest dime, and then output that in a pretty way. Output the price, output the rounded sales tax, like a divider line, and then the total price. So follow the comments. It should help. But here's kind of how it'll work. So 12.20. So if the price is $12.20, we're going to calculate 7.75% sales tax on that. In case you've never done that before, let me show you. Let me break out my trusty calculator program after I resize this window and not close it. And it's really not letting me resize in the way I want to right now. I just want it to be small, please. All right. Python 3. There we go. Okay, cool. So here's my calculator. If you have a price and you want to calculate what is 7.75% sales tax of that, do we remember how to calculate percentages? It's times 0.0775. It's like the percentage times 1 over 100. Yeah, times 1 over 100. So you move the decimal place. This is how you calculate 7.75% sales tax. This is 7.75% as a number. So that's the real sales tax, this fancy thing, but we're rounding this to the nearest dime, right? So it's 94 cents, 9.45-ish cents, and we need to round this down to 90 because it's closer to 90 than it is to a whole dollar. Do we see that? That's the rounding that needs to take place. And so it's 90 cents sales tax because we're rounding to the nearest dime, and then you're just going to output this in a pretty way with 2 decimal places, and a dollar sign in front. All these cool equal signs, 2 spaces on these lines. So you're going to make it pretty. But the trick is going to be how to calculate the sales tax and round it to the nearest dime. So here's another example. So 47.30. What's the sales tax on that? 775 again. So that should be apparently the real sales tax. If you could have infinite decimal places, it would look like this. But we're rounding to the nearest dime, so it should round up to 370. You see that? That's the closest one. 360 is farther away. So 370 is your sales tax, and then that brings the total to $51 even. Final example, 54.30, 7.75% of that is $4.20.85 whatever cents. This is of course very close to $4.20, and so that would be your sales tax. Add that to the price, and that's your output. Any questions about that? The output's very simple. It's the computation that I'm making you think about. How do you do that? How do you round into the nearest dime? I'll help you. If you ask me for a hint, I'll give you a hint. I've also written one at the end here, but just follow this syntax. Follow the comments. It should make sense. So here's my hint for you for rounding to the nearest 1/10. I put it here. I could help walk you through this, but this is something you can read if you're interested. That should give away the answer, I hope, if you can't think of it. But that's the second part. Any questions about that? So you're filling all these fixed me's. You got the price from the user. Now you got to work with it in this fancy way, in this universe where there's no pennies or nickels. All right. So just be thankful this is not like I'm pretending there's only no pennies, because that would be even harder to round to the nearest 5 cents if there really were nickels still. So, all right, so that's that one. And so those are your 2 programs for this lab. You're going to turn them both in with their names, just like this, in the way you know how now. And I think, yeah, they're weighted the same. Question?
How can we access the
starter code? Yeah, so that's what the gimme command will give to you. For lab 0, it's just it gave you 3 blank files because I wasn't very nice to you. I wanted you to do everything. But now you know how to make a main function. I trust that. So I've given you some starter code for real now in this gimme command. Yeah. Any other questions?
Real quick. So if we were to do that command in basically our root folder, then that would give us those files in the root folder. But if we did that in like a lab 0 folder or lab 1 folder, then that would give it in the lab 1 folder.
Yeah, it's always going to make a new folder called the name of the lab. But yeah, the second you say gimme, it'll make that folder wherever you currently are on the terminal. Yes. Very nice. Question in the back, yes. Oh, well, I will fix that in a second, if that is true for everyone else. Okay, you just might be misspelling it, but I will come to you in just a second. Let me stop this recording, and then I'll get right over.